Okay, let's take a look here. Review this stuff. All right. So we'll spend the rest of the time in class here kind of going over this. See if you have any questions. I'm going to go as quickly as you want me to go. So if you need to ask about something, please have me stop, slow down. We'll go over something. Okay. But yeah, let's focus in here. All right, for the next 25 minutes or so. Make sure we got this stuff down. Questions tomorrow will be very similar to these kind of questions. Okay, so you can get as prepared as you want to, basically, for that test tomorrow. Okay, here we go. So, graph f of x, and please, when you're reading these problems, I know there's sometimes a lot of reading, but do read all pieces of information because sometimes, all of it's important. So, the graph of f of x equals the cube root of x is shown, so there it is, okay, with a point D, 8, 2 plotted right there on the graph. So there's point D. The graph f of x is then translated to form the new function of g of x. If g of x is f of x plus 2 and then minus 5 on the outside, what are the coordinates of point D prime for this function g of x? Okay, so what kind of transformation? G is f, but it's transformed. How is f being transformed to get g? What kind of transformation do we see here? Left 2 and then?
Down 5.
Down 5, right? So left 2, okay, down 5. So point D will also be transformed in the same way. So all we have to do is just count. Left 2, down 1, 2, 3, 4, 5. And there is where point D prime will be. What coordinates are D prime? What coordinate is D prime? 6, -3, letter B. Okay? You got one right. All right. Okay, number 2. The step function graph below shows the GPA score for a given percentage in a class. Which ordered pair does not belong to the function, and it's not, there's an error there, so you don't have to worry about that part, okay? Which one of these ordered pairs does not belong? You guys tell me, which one of these ordered pairs does not belong on our graph here? 90 and 3, let's check it out. Here's the x-coordinate 90, There's 90, 3, what's wrong with this point? Open circle. Does it count as a point? No. We keep going. 90 and 4 is a point, so it's this one's the wrong one. I mean, that's the correct answer because it does not go around. Okay? So C. All right, number 3. The table to the right shows the values of a function. Which best describes the type of function shown in the table? Okay? So what do you guys notice is happening here in the table? Same but reverse. So -10, what do you mean by the reverse there? Can you be more mathematical in your... Okay, so -10 becomes positive 10, -8 to 8, and then 5, it doesn't become -5, it stays positive 5, right? Okay, so yeah, so what kind of function does that indicate here? BK, can you put the phone away? I want you to be following along. Make sure you get this stuff down, okay? It is absolute value, that's right. E is your answer for number 3, E. Okay, Jeff, Amber, you guys okay on that?
Yeah.
E is the answer. Okay, Colin, Dry, you guys okay on that too? Okay, Dry. Oh, you're there. Good. Okay, number 4, Tomas. Tomas is cycling from home to soccer practice. Tomas starts at his house and has a nice flat stretch of road for the first 3 minutes, and he travels at a speed of 12 miles per hour. Then Tomas gets to the bottom of the hill and has a 2-minute incline cycle at a speed of 4 miles per hour, so slower. He gets to the top of the hill and gets to cycle downhill next for 1 minute at 20 miles per hour. And the final stretch is just slightly uphill, and he cycles this for 5 minutes at 10 miles per hour. Okay, so here's our piecewise function. There's him riding the nice flat stretch. Then he slows down going uphill. Then he speeds up going downhill. And then he continues going 10 miles per hour for the next 5 minutes. Okay? Which one of these piecewise functions matches that situation? Which one of these piecewise functions matches this situation? Don't know?
Well, you take it educated guess. I'd say D.
D, okay? So it cannot be D. Here's why. D, if you look at all of these, kind of arguments here, they all start at 0. Do all these lines start at 0?
Could it be B?
Yeah, so it can't be D, and therefore it also can't be C. The answer is going to be B here. That is correct. Okay? Why didn't you say
that?
Why didn't
I
you
didn't know. I just guessed. Like
So-
you took educate. Yes, I did too.
Yeah. Why isn't it A?
Good job.
What's wrong with A that B has right? What's wrong with A that B has right? Yeah, so all the y-intercepts in A are what? What are all the y-intercepts in A? What are all the y-intercepts in A? What number are all the y-intercepts here? What's the B value here? They're all what? There isn't one, so what number can we put?
0.
0, right, 0. Okay, if you look here, right, that's right, okay, very good. Okay, so this one has a y-intercept of 0, but if I extend this line, will it go through 0? No, right? If I extend this line, does it go through 0? No, right? If I extend this line, it might go through 0, yes. Okay, so in other words, it's got to be B. In fact, this one doesn't quite, it goes through +4. But anyway. Okay, B is the answer there. Questions on that?
No, sir.
Okay. Number 5. The graph of f of x equals the square root of x, and its image, g of x, are shown below. So here's f of x. There's the image of it, g of x. Which equation expresses the value of g of x in terms of f of x? So which one of these gives us this result here? A, B, C, or D?
I think A.
So if you look here, what is A saying? Amber, what is A saying? A is saying that g is the same as f. Does g look like it's the same as f? So it cannot be A. So again, it is a reflection, right? So which is the answer though? It is going to be C here, okay? To check yourself, you can use your graphing calculator, okay? Go to your y equals here. We'll graph the square root of x, okay? And I'll check C. So you can see that g is equal to f of negative x. So where should that negative, Colin, Amber, where should that negative go for letter C if I want to check it? Inside. So yeah, next to the x, just like that. So I'm going to graph root x and then square root of negative x. And we graph it, look what happens. There's square root of x, there's square root of negative x. You see it? Okay? C is the answer. All right, number 6. What is the domain here? Yep. I was going to say, you guys better get this one. I don't need to help you with this one. Okay? What's the range? Okay, 5 is the biggest y value, but that's going to be at the end, and then negative infinity to 5. Okay, so make sure you put it in the right order. It should be negative infinity first, then the 5. You always go bottom to top. Left to right, bottom to top. Okay? Number 7, what can we do to help us get this one? Calculate, right? Well, let's talk about the shift, though, here. Okay? Colin, what kind of shift are we going to have in this graph?
Left 4.
Left 4?
Down 2.
Down 2. Plot your point, right? We can go to the graphing calculator to get some more points if we want. Okay, go to the table. So there's my starting point, negative 4, negative 2. I can get negative 3, negative 1 on there. Okay, I can also get 0, 0 on there. And I think I can fit one more. Maybe. Yep, 5, 1. That'll fit too. Okay, so connect the dots. There's our graph. Questions on that? All right, moving on. Okay. The graph below is of the function f of x equals negative 3 times absolute value of x plus 2 plus 3. Okay, so there's that graph for us already. See, left 2, up 3. And then the slope is down 3, right 1, down 3, right 1, and then by symmetry, down 3, left 1, down 3, left 1. Okay. What would change, or what change would be seen if f of x minus 4 were graphed? What is that minus 4 going to do? Down 4, right? When you have a minus 4 on the outside, that shifts things down 4. So the answer is D. Down 4 units. Okay? Okay? 9. functions f of x and g of x are given in the graph. Okay, A asks us to find f of 7. How can we use our graph here to find f of 7?
It's just right there.
Just right there. So 7 is an x or a y value?
Y. X.
He replaces an x, right? So it's an x value. So we'll go to the 7 on the x coordinate here, x-axis. What is the value of f at 7? What's the value of f at 7?
No, -2.
You see, guys, right here, -2, right? There's f of x at 7, it's -2, so the answer is -2. Okay? G of what? G of what gives us -1? So what x value can we plug in here so that when we take g of that, we get -1? G of what x value gives us -1? So here's g, right? Here's where the y value is -1. When does g equal -1 for what x value? 3. Yeah, right there. 3, right? 3 gives us -1. So g of 3 gives us -1. So you see the difference here? In letter A, we found f of 7. That's a y value. Here we had to figure out the x value that gave us this y value. Kind of backwards. Okay? Excuse me. If x is less than 3, so here's x equals 3. If we want to look less than 3, which direction are we going to look? For less than 3 is
left.
to the left. Yeah. Okay? Then f of x is equal to g of x at what point? So if we're looking to the left of 3, where does f of x equal g of x?
Is it where the intersect?
Yeah, where they intersect. What coordinates?
1,
Yeah, 1, -3, right there. Okay, that's all there is to it. Why do they have to specify x less than 3 here for this question? Why do they have to specify this for this question? Okay, I see you can't be equal to. I think you could put an equal to there and still get the same answer. But you'll notice, if you were just asked, where does f of x equal g of x, how many answers are there to that question? 2. Okay, but you'll see we only have one answer. So to help you figure out which one of the two, we said x has to be less than 3. So you can only consider this part of the graph, which means it's only this one, right? It could be this one if we didn't have that part. So again? For the less than, yeah, for less than 3. Yeah.
Also, when it's negative.
Say one more time.
Would it be like? Never mind.
Okay. This is just telling us, BK, that we only want to consider the part of the graph that's to the left of 3, for x less than 3. Okay, let's identify the equation for g of x. So here's g of x. Can you guys tell? How is it transformed? Here's g of x, right? How is it shifted? Here's g of x. How is it shifted? Where should... Yeah, I'll hold off on that question. I'll ask again. G of x, folks, how is it shifted? From where? Okay, it was shifted right how much? 2, right? You can see here's our central point. That is 2 units to the right of the origin. So it shifted right to, how else is it shifted? Down how much?
3.
If I go down 1, 2, 3, that wouldn't quite be right.
So 4.
Down 1, 2, 3, 4 is right here. I'm not talking about F, I'm talking about G. How is G shifted? Right, here's the center point of G. Here's that turning point, the center point of G. It shifted right to and down how much? From the origin here, guys, right? We always are counting from the origin. From the origin, how is it transformed to get to g of x here? Right to, and then what? Down to. Okay? How do I write that? If I want to say right to, I'll put an x, and then what? For right to, I put what here? Minus 2. Okay? And then how do I shift down to? I should add a negative 2. Okay? There's the equation. Okay. How about our absolute value? How is that shifted? Jirai, can you tell me that? How is f of x shifted?
Okay.
Here's our vertex, right?
Yeah.
How is that shifted?
Over 3 down to 4.
Okay, so I'm going to put x. If I want to go over to the right 3, what should I have here? Plus a
3.
plus a positive 3?
Negative.
Yeah, we're going to shift right 3, right? And then if we're shifting down 4, what should I? Negative 4, there you go. Now, how about this number out front, BK? How about this number up out front? What should go here? How's our slope kind of going here with this thing?
And up
Up how much?
a lot. 3, 1.
Okay, we go up 3, 1, 2, 3, and then over how much? 1, 2, 3,
6.
4, 5, 6. So 3 over 6, which simplifies to 1 over 2, right? So 1 over 2. So we can put a 1/2 in front. Okay? You can put 3/6 if you want to, BK, but 1 over 2 is best to simplify. Okay? So up 1, right 2, up 1, right 2, up 1, right 2. That gives us the slope there. Okay? Okay, what's the domain of G? What's the domain of G? There's no arrows at the end, but you can assume there are. Okay, so there's G. It should have arrows there. What's the domain of G? Let's go to Isabel. Isabel, what's the domain of this function here, G? Okay, domain. So what's the farthest left that G goes here? Negative infinity. What's the farthest right that G goes here? There you go. So that's the domain, okay? Because the leftmost part of G is pointing to the left. The rightmost part is pointing to the right. So we're going to go all the way to the left, all the way to the right, okay? Range, okay? Let's, Kemper, what's the range here for F? So F is the absolute value function there, Kemper. What's the lowest Y value here in F of X?
-4.
Okay, and it goes up to what? Yeah, there you go. Okay? All right, last two pieces here. 10, given the function f of x equals 2/3 absolute value of x plus 3, write f as a piecewise function that does not include absolute value symbols. We'll do that one second. I'm going to do this part first. Graph f of x on the coordinate grid to the right. Okay, so let's graph this thing real quick. Okay, Amber, how is this thing telling me to shift?
To down thing?
Nope.
Left 3.
What?
Left 3.
Left 3, right. The number on the outside tells us up or down there, okay, Amber? So left 3, 1, 2, 3, and then what's our slope? From this point, I'm going to go which direction? Up to? Over 3, right? Up to over 3, and keep doing that. Up to right 3, up to right 3, up to right 3. And so the up to right 3, we can go up to left 3, up to left 3, and then I'm kind of out of space, so I'll just do this. Okay? So there's part B. Check we did that. There's the graph right there. Okay? Now you write a piecewise function. How many parts does this piecewise function need? 2. Right. You can see 2 parts, right? Here and here, right? Okay, so I'll write f of x is equal to, okay, let's deal with this part first. This is going to be the easier. Actually, no, we have to do the leftmost part first. Let's do this part first. Okay? So if I look at this part, how would we describe that part? What is it? What kind of graph is that? What is it? Yeah, it's linear. Okay? To write the equation of a line, we need a slope and a y-intercept. What's the slope of this line? Yeah, negative 2 over 3. Now the y-intercept, does this graph cross the y-axis? No, we can make it cross it. So let's just keep going down 2 and right 3 one more time, and there's my y-intercept at negative 2. Okay? This graph, it starts from negative infinity, and where does it stop being this graph?
What in the world is that?
At what x value does it stop being this graph?
Shane, what did you call it?
X value.
-3.
Negative 3.
My boy, how you been? You got my McDonald's for me?
Okay. Oh, thank you. That's it. Okay, and then how about this last piece right here? What's the slope of this piece? What's the slope of this piece?
That's 1.5 over 1.
Yeah, so, or I'm going to say up to right 3. Yeah, so 2 over 3. Okay, what's the y-intercept of this piece? Not a trick question. What's the y-intercept of this piece? 2, so plus 2. And we'll say then from -3, because it starts at -3, I'll put less than or equal to for this one, and then less than infinity because it keeps going. Okay, there's your piecewise function right there. Okay, questions on any of that?
How do you know if it's, if we make it
Less or equal to? You kind of have some freedom here, Cameron. So, say again? Oh, how do you use those symbols? So, I would say when you're writing it for yourself, you're going to want to put x in between two less than symbols. Okay? So you see I have less than x less than, and here's less than or equal to x less than. Okay? So just because this really means x is greater than the negative infinity, but x is less than -3. This basically shows that x is between these two numbers. So if you just write it this way, that'll let you just put x between whatever two numbers you want. Okay? Okay, guys, we made it. Tomorrow's the test. Okay. Any additional set requests for today? Isabel, I already put you in. Kemper, I put you in. Ashton, I put you in. Okay, so this was recorded. I'm going to post it to Schoology, okay?